In this video, I want to graph these 6 inequalities and just talk about how to graph inequalities. And so the first thing I'm going to do in each instance is I'm going to graph an equation. I'm going to ignore the inequality symbol itself for the first moment and just pretend it's an equation. The only bit of information I'm going to take from the inequality is whether to use a solid or a dotted line. If I see an equals to, like in this one that says x is greater than or equal to 4, I'll use a solid line. If I don't see an equal to, I'm going to use a dotted line. So starting with this one, just to start, I'm going to imagine graphing x is equal to 4. And I'm going to imagine doing that with a solid line because it's a greater than or equal to. Well, the equation x equals 4 is just a vertical line going through x equals 4. Literally, it would be the equation where all the x's are 4 and y gets to be whatever it wants to be. And now looking at this equation, I'm supposed to shade where x is greater than or equal to 4. Well, that would be all the x's over here. And one way you can check that is by picking a test point. And so on the x-axis here, if you pick 5, 0 and plug it in, well, 5 is bigger than or equal to 4, and we have shaded the correct side, also the right side. And any point in here, right? Like if I pick that point, maybe that's the point 5, 6, 7, maybe 4, 7, 4. Well, only the x-coordinate matters, and 7 is greater than or equal to 4. And we've shaded that correctly. Moving on to the next one, y this time is less than 2. Well, again, I start by graphing an equation. I'm going to start by graphing y is equal to 2, but this time with a dotted line, because my inequality doesn't contain the condition of equality. There is no equal to. So these are all the points where y is equal to 2. They don't solve this inequality, and that's why I'm using a dotted line, because this says y is strictly less than 2. All right, well, now I'm looking to shade points where the y value is smaller than 2, and that's all the points below this line. And again, we could pick a sample point like the origin. The y-coordinate at the origin is 0, and 0 is less than 2. Or we could pick a point like 1, minus 1. Minus 1 is also less than 2. And we've shaded the correct part of the plane. All right, so now I have 2x plus 3y is less than 4. So to start, I'm going to graph an equation. 2x plus 3y equals 4. And because there's no equal sign here, I'll use a dotted line. Well, I'm just asked to graph a line, and I could do anything I wanted to here. I could get y by itself and use slope-intercept form, but I think what I'll do is I'm just going to find the intercepts and graph this line using the intercepts. So if I let y equal 0, I would get the equation 2x is equal to 4, so the x-intercept is 2. If I let x equal 4, I'd get 3y equals 4, and so the y-intercept is 4/3, or 1 and 1/3. So I need to graph that line with a dotted line. And now I need to figure out which side I'm shading, right? Am I shading above the line or below the line? And so here I can just pick a sample point like the origin, and I plug it in, I get 2 times 0 plus 3 times 0 is 0, which is less than 4. So if I pick that point, I get lucky and just shade that side. But I wanted to think about that line one other way. And so I'm actually going to move over to another board and come back to this picture. But that inequality was 2x plus 3y is less than 4. And so one way to go about this is to get y by itself. And so if I do that, the equation I would have graphed would have had a slope of minus 2/3, and that matches what we did. And then the y-intercept is 4/3, and that's what we said it was. So this is the equation I'd graph, but if I thought about using the inequality symbol through all of the calculations, well, this would have just stayed a less than when I took that away. And when I divide by a positive number, I leave my inequality symbol alone. If I multiply or divide by a negative value, then the inequality symbol would change. But this is the way I wanted to think about it. Because these are the y values that are less than minus 2x plus 4 over 3. So solving this gives me y is less than minus 2/3 x plus 4/3. Well, the dotted line, those are all the y's where, those are all the points where the y values are equal to minus 2/3 x plus 4/3. So this literally says y is smaller than that, so that would be the underside of the line. If I get y by itself and it's a greater than symbol, well, then I would need to shade above the line. And that's one of my favorite ways of thinking about these, is if I can get y by itself on the left-hand side, it's telling me whether to shade above or below, just the way this one was. If I get x by itself, then I have to think about lefts and rights. So let's move down to number 4 here. So I'm going to graph y is equal to x squared, which is just that nice happy parabola that we saw a long time ago. I'm graphing it with a solid line because this is a greater than or equal to. Y is bigger than or equal to x squared. Well, this green parabola, those are all the spots where y is equal to x squared. The y values, the points with y values larger than that are the ones above the parabola, or here it kind of appears like it would be on the inside, going up forever. Like I need to keep shading it, but I'm gonna just stop there because I have to stop somewhere. All right, 2 more to go, and I realize now what's going on with this pair of problems, right? It's the same line. The inequality symbol's just been flopped, and now it's a greater than or equal to. Pause the video here and try 5 and 6 on your own, and then I'll show you the solutions. Okay, so for number 5, I'd have exactly the same line, except for this time it would be a solid line because I see a greater than or equal to. And if I thought about solving for y, the only thing that would change would be the inequality symbol. Everything else would remain the same. So instead of shading below the line, now I can shade above the line. And if I wanted to check that with a sample point, I could imagine picking the point 2, 2 and making sure that satisfied this original statement, or this one, but I know this one's right, so I'm going to use it. So 2 times 2 is 4, 3 times 2 is 6, and 10 is bigger than or equal to 4. So I feel really good about that one. And now one more inequality to graph. I'm asked to graph another parabola. This time it's my parabola y equals x squared, but shifted up 1 unit. So my vertex will be here. And this time I graph my parabola with a dotted line because that's just a greater than. There's no equal to. Not a great parabola I'm graphing here, but that'll work. And y is bigger than x squared plus 1, so I shade all the y's that are above the parabola. And again, if you want to check this with the sample point, well, that's a good one. That's 0, 2. And 2 is greater than 1. And so that works. So now we've graphed 6 inequalities.